focus and talk about derivatives and the tangent line problem. So up until now, we have talked about limits quite a bit, and we've talked about derivatives a little bit, and now we're going to see how these actually relate to one another and why we've kind of been tackling this. Well, if we have a function, the way that we find the derivative is by finding the rate of change, right? Well, to find the rate of change, we're just going to find the slope of a graph. Well, to find a slope, you need 2 points. So if I have this graph here, and I want to find the slope, I can use the points between P and Q to find the slope of this line, right? This is called our secant line. But this is not actually as accurate as it can be. And in order for that to get more accurate, we can move that point P even closer and draw another line, right? And so this line, you can see these weren't drawn accurately, but I think you get the idea that this would actually be more accurate to find the rate of change at point P. And as we get even closer, we can get Q like infinitely closer to P, then we end up drawing what becomes our tangent line. There's our tangent line. And that tangent line gives us the slope of the curve at a specific point. So actually, you could find the slope of the secant line by having like a change of x here and a change of y here and kind of calculating that. But really what we're interested in is the definition of the limit. And the definition of the limit states, or I'm sorry, the definition of the derivative. The definition, I'll write this down, definition of the derivative states that f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. This is it. This is what we're going to be using, right? So let's talk, before we move on to this, just a little bit about derivative notation. There are multiple ways to write the derivative. You can write f prime of x, right? That's maybe my favorite way, f prime of x. You could write y prime, that's the exact same thing. You could write dy over dx, that d stands for the derivative, so like the derivative of y with respect to x. You could write df over dx. This one I do not see very often. What's the derivative of the function with respect to x? Or sometimes you'll see d over dx of the function f of x, right? This one will become useful when we deal with implicit differentiation in the future. Can you see all of that, hopefully? So now that you know what these derivative notations are, we can kind of dive back into our derivative. We've already talked about this definition, which is very useful and great to have, but we actually also have an alternative definition of the derivative. So I'm going to write that out. The derivative at a point x equals a is also found by f prime of a is equal to the limit as x approaches a of f of x minus f of a over x minus a. And that should look pretty familiar to you, right? That's basically the slope formula that you've been using for years and years and years. So let's actually do one of these. I think it's going to make more sense when we actually go through the process a little bit. So we want to use the limit process of the derivative to find the general formula for the derivative of f of x equals 2x squared minus 3x. What we're going to do is use that definition that we have before, the limit, f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x over h. Did I write that right? Better check. X plus h minus f of x over h. Okay, good. Oh, and I smudged it all, but hopefully you can still see. So we're going to use that to actually figure out what's the specific derivative for this function right here. So f prime of x is going to equal the limit as x approaches, or not x, as h approaches 0, as h approaches 0 of, and now I'm going to put in an x plus h wherever I have an x. So we're going to have 2 times x plus h squared minus 3 times x plus h minus, and I like to put this in parentheses, f of x is 2x squared minus 3x, all divided by h. So let's break this up a little bit. See if we can simplify things here. We're going to have 2 times x squared plus 2xh plus h squared minus 3x minus 3h minus 2x squared plus 3x all over h. And I probably should have multiplied that through before, but I didn't. So I have 2x squared plus 4xh plus 2h squared minus 3x minus 3h minus 2x squared plus 3x all over h. I'm going to cancel some things out here, a plus 3x and a minus 3x, and minus 2x squared, positive 2x squared. So now I've got the limit as h approaches 0 of 4xh plus 2h squared minus 3h all over h. I can divide h in. So this is the limit as h approaches 0 of 4x plus 2h minus 3. And now I actually find my limit. Well, as h goes to 0, this is going to become 0. So this is just going to be equal to 4x minus 3, which is our derivative. And this is actually probably the most complicated way to find the derivative, and we will certainly find easier ways in the future, but that's it. This is the derivative. This is the formula for the slope of that original graph, and we can use this formula to find the exact slope, the exact rate of change at any point. So let's, excuse me, let's do another example here. We want to use the alternative form of the derivative to find f prime of a, for f of t equals the square root of 3t plus 1 at a equals 1. Well, first thing that we're going to need, we're going to use that definition, f prime of a is equal to the limit as x approaches a of f of x minus f of a over x minus a. Well, first we need to find what is f of a. So f of a, in this case, a is equal to 1. I should write that down. F of 1 is equal to the square root of 3 times 1 plus 1, which equals the square root of 4, which equals 2. That's nice and convenient for us. So f prime of a, f prime of 1 in this case, is going to be equal to the limit as x approaches 1 of f of x is the square root of 3t plus 1 minus f of a is 2 over t minus 1. And I wrote x here, but our variable actually is t, so I should be using that. So now we can kind of just work through this and solve. We've got 3t plus 1 minus 2 over t minus 1. I kind of want to get rid of this radical as best as I can. I'm going to multiply by the conjugate, 3t plus 1 plus 2 over radical 3t plus 1 plus 2. So now I have the limit as t approaches 1 of 3t plus 1 minus 4 over t minus 1 times square root of, oops, way too much square root going on there, 3t plus 1 plus 2. All right, so far so good. And I can kind of rewrite this. I've got the limit, hopefully you can still see here, the limit as t approaches 1 of 3t minus 3 over t minus 1 times the square root of 3t plus 1 plus 2. That's going to be our limit. It's t approaches 1 of 3 times t minus 1. Looks like we're going to get something to cancel out here. 3t plus 1 plus 2. These cancel out. So now we have the limit as t approaches 1 of 3 over the square root of 3t plus 1 plus 2. And as t approaches 1, we're going to get 3 over the square root of 4 plus 2, which equals 3 over 2 plus 2, which equals 3/4. So that's our slope at f prime of 1 is equal to 3/4. Kind of fun, huh? All right, let's do 2 more examples. For the function f of x equals x squared minus 3x plus 2, find a general formula for the slope of the tangent line to any point of the curve. Then use the general formula to find the slope of the tangent line at x equals 2 and x equals 0. Well, that general formula is that formula that we used before. We're going to use the limit of, or the limit definition of the derivative to find that general formula. So the limit as h approaches 0 of, we've got what here? X plus h cubed, nope, squared, thank goodness. Cubed would be kind of a bit of a nightmare for us. X plus h squared minus 3 times x plus h plus 2 minus x squared minus 3x plus 2 all over h. So we've got our limit as h approaches 0 of x squared plus 2xh plus h squared minus 3x minus 3h plus 2 minus x squared plus 3x minus 2 all over h. Looks like we've got quite a few things that are going to cancel out here. So x squareds are going to cancel out. My 2's are going to cancel out. 3x's are going to cancel out. So now I have 2xh plus h squared minus 3h all over h. So our limit as h approaches 0 of 2x plus h minus 3. And as the x approaches 0, this is going to be equal to 2x minus 3. Beautiful. That's our derivative. That's f prime of x. That's the general formula. So now we want to find f prime of 2 and f prime of 0. Well, f prime of 2 is just going to be 2 times 2 minus 3, which is 4 minus 3, which equals 1. Prime of 0 is 2 times 0 minus 3, which is just 0 minus 3, which equals negative 3. So pretty simple. All right, one last final example here. Use the limit definition to compute f prime of a and find an equation of the tangent line for f of x equals 1 over x plus 3 when a is negative 2. Well, the first thing we need is f of, oh, ignore all of that. We need f of negative 2. Well, f of negative 2 is going to be equal to 1 over negative 2 plus 3, which is 1 over 1, which is just 1. Beautifully convenient. F prime of negative 2 is going to be equal to the limit as x approaches negative 2. Remember, we're using all alternative definition here of 1 over x minus 3 minus f of a is 1. We already found that. Over x minus a negative 2 is plus 2. Okay? So I'm going to kind of deal with our fractions here. So we're going to have 1 minus x minus 3, 1 minus x minus 3, excuse me, over x minus 3, right? Did I do that right? All over x plus 2. I'm going to pause for a second and check my work. Okay, I think it's right. We'll find out if I'm wrong later, and maybe you can correct me in class. So I'm going to have 1 minus a negative 3 is 1 plus 3 is 4. So I have negative x plus 4 over x minus 3 all over x plus 2. So my limit as x approaches negative 2 of negative x plus 4 over x minus 3 times x plus 2. And that's going to give us a 0 there. I feel like I've made a mistake somewhere. I'm pausing again. Okay, I found my mistake. So actually, this should be plus 3. Plus 3, plus 3, plus 3. So 1 minus positive 3 will become a negative 2, right? So now, this all gets erased down here. So I should have, this is going to become 1 over x plus 2, and if I take that out, it's got negative 1, so it's going to be negative 1 over x plus 3, and as x goes to negative 2, we've got negative 1 over negative 2 plus 3, negative 1 over 1, which equals negative 1. So that is equal to f prime of negative 2. I gotta fix that again. Okay. And our tangent line, we still are asked to find the equation of the tangent line. Our tangent line equation is going to be y minus, well, y sub 1, right? This is our x, this is our y, so y minus 1 equals, our slope is negative 1, that's our m, negative 1 times x plus 2 minus a negative 2, right? So I can rewrite this as y equals negative x minus 2 plus 1. So y equals negative x minus 1. This is correct. This is correct. You could also write negative 1 times x plus 2 plus 1. This is correct. They're all the same thing, right? Okay, so hopefully all of that makes sense. And I'll work together with you in class. Any comments or questions, leave them in the comment box below, and I look forward to seeing you. Bye!